Do you know how much you weigh? If not, what is the best way to find out? That's right, you can step onto a scale. Now, here's another question. Would your weight change if you took your scale to the moon and weighed yourself there? In fact, you would weigh much less on the moon than you do here on Earth. Why? In this lesson, we'll answer this question as we take a closer look at what defines weight. Let's imagine that you're standing on a scale to find out your weight. As you stand on the scale, it's actually measuring the relationship between you and a particular force. Can you guess which force that is? If you said gravity, you are correct. Weight is actually a measure of the amount of force that you exert on the scale. This force is due to the pull of gravity. Gravity, as you probably already know, is the force that pulls everything down. Whether we're talking about an elephant or a feather, gravity hugs everything to the Earth in the same way. Since the force of gravity is always the same, why do different objects weigh different amounts? The answer lies in how much matter the object has. Okay, so what is matter? Just about everything is matter. For starters, you are matter. The chair you are sitting on is matter. In fact, when you look around, everything you see is matter. But that's not all. Even the invisible air around you is matter. That's because matter is anything that has mass and takes up space. When you multiply the amount of matter in something by the force of gravity, you get that thing's weight. Matter times gravity equals weight. As you might guess, the more matter on the scale, the higher the weight. For example, you can take a balloon and set it on the scale, recording its weight. Next, blow up the very same balloon. Now you have added matter to that balloon in the form of air. This creates more force and therefore more weight. Let's take a look at another example. When you go to the doctor and they weigh you, you're probably asked to take your shoes off. That's because the scale measures the weight of everything on you, or all the matter that's on the scale. In this case, your total weight would equal the weight of your body, undergarments, shirt, pants, socks, shoes, and accessories. Since shoes tend to be the heaviest of those things, removing them means the doctor can get a more accurate weight measurement. In the beginning of this lesson, we mentioned that you would weigh less on the moon than on Earth. Is that because your body shrinks? Of course not. Your body has the same amount of matter wherever it is. However, the pull of gravity is lower on the moon than on Earth. Therefore, you would not exert nearly as much force on a lunar scale. Matter is anything that has mass and takes up space, and gravity is the force that pulls everything down, and weight is a product of the force of gravity on the matter of an object. Objects with more matter have more weight. When a scale measures weight, it measures the weight of all the matter that's on it. While an object may weigh a certain amount on Earth, it will weigh less on the moon. Even though it still has the same amount of matter, there is a smaller force of gravity on the moon, so weight will be different than that on Earth.